be talking about some of the week 1 homework problems. So I'm going to work out the solutions here. I'll give you some feedback on the grading, but you should mostly watch this video to get a feel for the correct solutions and understand any mistakes you have. If you don't understand the mistakes, then you should let me know and we can talk about your individual work. Okay, so today we're going to be talking about number 2. And so we're looking at a few conditional statements and we're trying to restate these different forms of the conditional statement. And most important here is to understand this contrapositive. But let's go ahead and understand the converse, contrapositive, and inverse so that we can understand how to go from just a general implication to these different forms of the conditional statement. So let's say we've got this conditional statement, just this general statement here with a hypothesis of P and a conclusion of Q. And again, you want to be careful about thinking about these variables and getting locked into that idea. You want to think hypothesis, conclusion, or whatever terms you have decided on. That is generally used in the text. But so the converse is just switching the order. Okay, the converse is conclusion implies hypothesis. And so if you notice from our work that we did within the truth tables in week 1, you should have noticed that P implies Q is not logically equivalent to Q implies P. Okay, so just remember that. That's, another way to think of this is that commutativity doesn't hold for commutativity, or we could just say implication, not commutative. The order that we do those P's and Q's matters. Okay? So we can't do them in any order. This is versus, right? If we have P or Q, this is the same as Q or P. So it's kind of like going from division, right? If division, like if I take 3 divided by 6, that's different from 6 divided by 3. But with multiplication, it's commutative, right? If I take 5 times 2, it's the same thing as 2 times 5, right? Okay. So this is just saying, they're not commutative operations. So that's the converse of the statement. So what we're going to do to find the converse is just flip the order. So when we're starting with our statement, if it snows today, I will ski tomorrow, we need to figure out and identify what the hypothesis is, and we need to know what the conclusion is. So what proposition is our hypothesis and what proposition is our conclusion. So this is just stated in the if-then form, so it's not too tricky to interpret. Had it been stated differently, make sure that you're familiar with those different ways of stating conditional statements in English, right? So I know that I got if-then, so my hypothesis is it snows today. So this is going to be it snows today. So when I'm looking at these other forms of the conditional, I'm going to think about this guy like P, okay? And my conclusion is I will ski tomorrow. And I'm going to think about this guy like Q. So if I'm trying to think about the converse of this statement, I know that if I'm looking at P implies Q, the converse is going to be Q implies P. So this means I'm going to start with my conclusion, I'm going to say if then, so if, conclusion, right? If I will ski tomorrow, then it snows today. And so I think this is a great example of why those aren't logically equivalent statements. I think you can kind of see that if it snows today, I will ski tomorrow. Doesn't mean the same thing if I ski tomorrow, then it will snow today. So that's a good example of that. Now let's move on to the contrapositive. And this week, you should have noticed that the contrapositive of a conditional statement is actually logically equivalent. And this is going to help us a lot in the proofs section. So it'll be important to know how to go from an if-then statement to its contrapositive so we understand how to manipulate the statement in that way. But it's really similar to what we just did with the converse. We need to identify the hypothesis and the conclusion. We'll also need to identify the negation of both of those statements so we can piece them together in that order. So when I'm trying to state the contrapositive, I think of two things. I think switch order of conditional, and then I think, okay, then I need to negate both of those statements. So switch order, negate. That's what I think of when I'm trying to write the contrapositive. So negate both propositions. Or predicates, right? We're moving to predicates this week, so you want to get comfortable with negation of predicates too. But for now, we're just dealing with propositions. So let's do the contrapositive of the statement. Contrapositive. So the contrapositive of P implies Q is just the negation of the conclusion implies the negation of the hypothesis. So we want to figure out what's not Q. How do I negate Q? So if I'm thinking about negating a statement, it's nice to start out, as simple and not too complicated. So when I think about negation, I want to just say it is not the case that. I'm going to start just by thinking about it in that way, and then trying to manipulate it and make it sound a little bit more clean and a little bit easier to interpret. So I'm just going to write, it is not the case that I will ski tomorrow. I will ski. Oops. And so you want to make sure that your negation of statement has the exact opposite meaning. And that means that if Q is true, then not Q has to be false. If Q is false, then not Q has to be true. And that always has to be happening, the opposite truth value. So you have to be careful if you're manipulating the way that you state this. But this isn't very understandable, right? You want to tell your reader something a little bit more, something easier to read and interpret. And that's not such a big deal now, but when you're going into a proof and you're trying to prove a conditional and you're trying to think about an equivalent statement, it's going to be a lot easier to interpret and prove and deal with those statements if you really understand what they mean. And I think that's a key part of going from it is not the case to, in this proposition, I will not ski tomorrow. You should be able to see that Q and not Q are still always going to have opposite truth values. So that's going to be not Q. Now I need to know not P. So if I'm looking at not P, I know that the negation of P is going to be, just means it is not the case P, right? So it is not the case that it snows today. So hopefully you can see that I can write this a little cleaner and a little more understandable if I just say, it does not snow today. And again, we're just practicing with the negation and these contrapositives just to help us understand how to write these logically equivalent statements or negations of these implications. It'll help us later on when we're trying to prove statements. We need to understand how to write them in equivalent ways to help us. Okay. So if we're trying to do the contrapositive then, we're going to piece together these two negated propositions to write an if-then statement. So I'm going to write if not Q, then not P. So if not Q, we said it's simpler to write I will not ski tomorrow. So if I will not ski tomorrow, then it does not snow today. So, I mean, the case is a little bit weird and doesn't make total sense, but the main idea is that you understand how to take an implication and write it in this equivalent contrapositive form. Okay. And then, yeah, just one more, right? We also need to write the inverse of our conditional statement. And so a lot of times people think that the inverse is the negation of an implication, but that's not true. What you should have realized, and maybe more in week 2 material, okay? In week 2 material, we're going to be proving logical equivalences using a series of replacements, okay? And so you might not fully follow me here if you haven't started looking at that, but what I want to talk about is the negation of P implies Q for a moment, okay? So what I would do, and I think your last exercise, I think you have to do truth tables of both of these statements, okay? And so I would do those and notice that they're not the same, okay? So that's a good starting point. But we're going to have to negate an implication, so it's important for us to figure out what that means. Somehow we want to put that negation in front of the propositions themselves, because if there's just a negation hanging out in the outside, it's not as easy to interpret as if we can move that negation in. So what I'm going to do, I know that P implies Q, so what I'm going to do on this step, I know P implies Q is logically equivalent to negation of a hypothesis or the conclusion. So I'm going to substitute that equivalence in, negation of P or Q, okay? And then I'm going to use De Morgan's laws. If I negate across an or, I have to negate both pieces of my or and change the or to an and, okay? So you should have seen this in De Morgan's laws. I think we're going to talk more about those in week 2. So I think, yeah, there's a video series from YouTube about key logical equivalences, so you want to make sure that you watch that, and these processes here will make more sense. And then we have double negation here. If I negate a negative, I just end up with that proposition in itself, so I'm using the idea of double negation. So then I get P and not Q. So notice, it's not the same. It's not negation of P and, or it implies negation of Q, right? It's something totally different. The negation of an implication is actually P and not Q. Okay. So let's go back to the problem here. I got off track here. We wanted to write this inverse based on the statement given. So, and what's nice is I already figured out what not P and not Q is, or what they are. So all I have to do is connect those together, and just in a different order than this one, right? So I'm going to start if not P, then not Q. So if not P is if it does not snow today, then not Q is I will not ski tomorrow. So think about these two statements and see if you can figure out why they're not exact opposites of each other. So why is negation of P implies negation of Q not the opposite of P implies Q? Okay, so why is if it snows today, I will ski tomorrow not the opposite of if I will not ski tomorrow, then it does not snow today? Oops. Here we go. No, it's not the opposite of if it does not snow today, then I will not ski tomorrow. So hopefully that got you started with the converse, contrapositive, and inverse. And I think you should be able to figure out the next two, and I'll post the solutions just so that you can check and understand. I think the only thing tricky on B and C is to make sure going into it that you understand what your hypothesis and what your conclusion are. And so to do that, go ahead and look at those different ways of stating conditional statement. And that'll help you interpret what's going on there with the hypothesis and conclusion. And just think through it a little bit, try to make a connection there. But so hopefully that helped you on number 2. We'll come back and do a few more exercises here. Thank you. 15 minutes. Oh, a little bit.